You're falling. You don't remember jumping. The sky above you is a sick, glowing orange, the color of a furnace door left open, and it's getting darker by the second. Your suit's external thermometer gave up 2 minutes ago. It just says error. Something hits your visor. Then again. Then hundreds of impacts at once, like a hailstorm made by something that hates you. Each drop glows red and leaves a molten streak across your faceplate. You look at your glove and watch a bead of liquid metal roll across the knuckle. Still glowing, still white hot. It's iron. It's raining iron, and it's falling sideways. Then the wind hits. 11,000 miles per hour. Your body is whipped horizontal so fast your vision goes gray at the edges. Your suit, the one they called indestructible, just cracked for the first time. This planet was not supposed to be survivable. None of them were. But you were sent anyway, to 7 of the most terrifying worlds ever discovered, each one worse than the last. Your suit was engineered to handle all of them. It won't. Let's start at the beginning. You've been assigned a one-way survey mission across 7 exoplanets ranked from terrifying to unsurvivable. Your suit is next generation, rated for temperatures up to 5,000 degrees Fahrenheit, winds up to 15,000 miles per hour. Each planet damages the suit. The damage accumulates. There are no repairs. And every single number you're about to hear, every temperature, every wind speed, every rain made of metal or glass is real. Measured by real telescopes, published in real journals. Nothing is made up, which, honestly, is the scariest part. Planet 7. Gliese 436 b, the burning ice planet. 30 light-years from Earth. You land on a Neptune-sized world orbiting a dim red dwarf. The ground glows. It's solid, but it's ice. Ice at 822 degrees Fahrenheit. This is Ice X, one of at least 18 known phases of water. The planet's gravity is so immense it compresses water into a crystalline lattice that stays rigid even at temperatures that would melt lead. Same principle that turns carbon into diamonds, except this diamond is made of water, and it's cooking you through your boots. The sky is dark reddish black. Lightning ripples through haze, and above you, invisible to your eyes but screaming in ultraviolet, the planet is bleeding. In 2015, Hubble found a hydrogen tail streaming off this world, 50 times larger than the star it orbits. 1,000 metric tons of atmosphere escaping every second. The weight of 200 elephants launched into space, every second, forever. The planet's methane levels are 7,000 times lower than every chemistry model says they should be. Nobody knows why. The math says the methane should be there. The planet says no. In 2023, the planet was renamed Awohali, Cherokee for eagle, after a legend about an eagle who flew to the sun and whose tail feather was kissed by fire. Poetic, because this planet's tail is being kissed to death. Your suit held. Minor heat stress. Hairline fractures in the boot soles. You don't feel it yet. Planet 6, HD 80606b. The Flash Roast Planet. 200 light-years out. You arrive, and the planet looks almost peaceful. It's far from its star right now, drifting through the cold outer reaches of its orbit. Then the instruments start screaming. This planet doesn't orbit in a circle. It falls toward its star on a path so elongated it makes Halley's Comet look tame. Every 111 days it swings from roughly Earth's distance all the way down to closer than Mercury. You watch through the viewport as the star swells to 30 times the apparent size of our Sun. In 6 hours, the temperature goes from 980 to 2,240 degrees Fahrenheit. The Spitzer Space Telescope measured this in real time. The team watched a continent-sized storm form from the heat pulse, a shockwave of superheated atmosphere, born in hours, visible from 200 light-years away. Then the planet cooled so fast it became invisible to Spitzer within 10 hours. A complete reset, every 111 days. The same nightmare on repeat. A companion star 1,000 astronomical units away is responsible. Its gravity pumps this orbit into these suicidal extremes through something called the Kozai mechanism. HD 80606b is mid-migration, slowly being squeezed into a permanent close orbit. A future hot Jupiter, currently in the process of having its life ruined. Your suit's heat shielding, already cracked from the ice planet, is now partially ablated on the starboard side. The cooling system is working harder than it should. Planet 5. Coro T7b, the disappearing planet. You land on the day side. The star doesn't rise here. It's fixed in the sky, enormous, permanent, like a searchlight bolted to the ceiling of a room with no doors. The ground is a churning ocean of molten rock, glowing white-orange. It's dense enough to stand on, but it clings to your boots like burning tar. The temperature at the substellar point is 3,994 degrees, as hot as the tungsten filament inside a light bulb. This was the first confirmed rocky exoplanet ever found, discovered in 2009. Sky-End Telescope's cover called it the planet from hell. They were being generous. The atmosphere is vaporized rock, sodium, silicon monoxide, atomic oxygen, at a surface pressure of 1.5 pascals, 1/70,000th of Earth's atmosphere. Thinner than the best vacuums we make in laboratories. And on the night side, silicate vapor condenses and falls as pebbles. It rains rocks here. Brian Jackson at NASA Goddard modeled that this planet may have once been as massive as Saturn. What you're standing on is the stripped, evaporating core of a dead gas giant, shrinking in real time, its surface boiling into space. Your boot soles are partially melted. Your visor coating is degrading. You're only on Planet 5. Planet 4, WASP-127b, the record wind planet. This time you don't land. There's nothing to land on. WASP-127b is a superpuff, 30% larger than Jupiter but only 16% of its mass. Marshmallow density, no surface. Just atmosphere that gets denser the deeper you fall. You hover at the equator. For a moment, it's almost peaceful. Then the jet stream finds you, 20,505 miles per hour. Mach 3, published January 2025 by Lisa Nortman at the University of Göttingen, the fastest sustained wind ever measured on any planet in the known universe. For context, Earth's strongest jet stream maxes out around 275 miles per hour. Neptune hits 1,120. This is 9 times faster than a bullet from a rifle. Your suit flexes in ways it was never designed for. Several joint seals are now micro-fractured. You can feel the faintest hiss of atmosphere seeping in through gaps that didn't exist 4 planets ago. 4 planets down, 3 to go, and mission control has gone quiet. Here's what they don't tell you in the briefing. The first 4 planets were a warm-up. Extreme, yes. Hostile, absolutely. But you survived them. You can still move your arms. You can still see through your visor mostly. The next 3 are the reason mission control stopped talking. These aren't just extreme. These are the ones that made the scientists who discovered them use words like hellish, nightmare, and shouldn't exist. The suit is at about half integrity. That won't be enough. Planet 3, WASP-76b, the Iron Rain Furnace. Remember the orange sky? The molten streaks on your visor? You're back, 637 light-years from Earth. You enter on the day side, 4,350 degrees Fahrenheit, hot enough to vaporize iron into gas. You drift toward the evening terminator, the border between permanent day and permanent night. And the temperature drops 900 degrees Celsius in a few hundred kilometers. The iron vapor that was invisible on the day side suddenly condenses into droplets. Liquid iron at 1,500 degrees Celsius, materializing out of thin air. David Ehrenreich led the discovery using espresso on the Very Large Telescope. Iron signatures at the evening terminator. Nothing at the morning. The iron vanishes overnight. It rains out. Published in Nature, March 2020. In 2024, ESA's CCHIOPS telescope found something stranger. Hints of a glory effect in the atmosphere, concentric, colorful rings like a rainbow bent into circles, previously only ever seen on Earth and Venus. If confirmed, the droplets causing it may be iron, a rainbow made of molten metal, but here's what rewrites your sense of scale. The dayside atmosphere is far more inflated than the nightside. The evening terminator isn't a weather line. It's a cliff, a vertical wall of atmosphere thousands of kilometers tall. Iron rain doesn't just fall, it cascades down a wall of gas the height of a continent, a waterfall of molten metal pouring from the edge of daylight into permanent darkness. Your visor is opaque now, scarred over from impacts. Your right shoulder joint is locked with iron deposits. The cooling system is failing. Planet 2, WASP-12b, the planet being eaten alive. 1,400 light-years out, and something is immediately wrong. The planet is the wrong shape. It's an egg, visibly stretched toward its star, which sits just 2.1 million miles away. The tidal forces have physically deformed a world nearly twice the size of Jupiter. It's also black, darker than asphalt. Hubble measured an albedo of 0.064, half as reflective as the moon. It absorbs 94% of all visible light, so hot that hydrogen molecules are ripped into individual atoms, and the atmosphere behaves more like the outer layer of a star than a planet. But it glows. A deep, angry red, like an ember buried in ash. Simultaneously pitch black and incandescent. And it's dying. In 2010, Hubble directly observed a stream of material flowing from the planet into a disk around the star. In 2019, Princeton confirmed the orbit is shrinking by 29 milliseconds per year. Updated 2024 estimate: it crashes into its star in 3 million years. Samuel Yee called it the first time we have caught this process in action. Douglas Lynn at UC Santa Cruz put it plainly: this star will not have WASP-12b to eat because the planet will have been totally disrupted long before then. The planet won't survive long enough to be swallowed. It'll be shredded first. Its atmosphere has already ballooned to nearly 3 times Jupiter's radius. It's inflated by tidal heating, the star's gravity squeezing and stretching it every orbit, pumping energy into the interior like kneading dough that's slowly tearing apart. You position yourself at the gravitational midpoint between planet and star. You float for a moment. Then you drift. Not toward the planet. Toward the star. The star wins. It always wins here. Your suit's inner thermal layer is breached. For the first time, you feel heat on your skin. Actual heat. Not a reading, not a warning. It is the least comforting warmth you have ever felt. Planet 1, HD 189733b, the glass storm planet, 63 light-years from Earth. And from a distance, you almost cry. It's blue. Deep, gorgeous blue, the color of the Caribbean, the color of Earth from orbit. After 6 planets of fire and darkness and metal rain, here is a world that looks like it has oceans. You enter the atmosphere. Within 5 seconds, you understand the scam. The blue isn't water, it's glass. Tiny silicate particles scatter blue light through Rayleigh scattering, the same physics that makes Earth's sky blue. Except instead of nitrogen molecules, it's shards of molten glass. Instead of a gentle breeze, it's 5,400 miles per hour, 7 times the speed of sound. NASA's official description of the weather here is 5 words long: death by 1,000 cuts. In July 2024, JWST added one more detail: hydrogen sulfide, the molecule responsible for the smell of rotten eggs. The most beautiful planet you have ever seen smells like a sewer and shoots glass at you at Mach 7. It's also the single most studied exoplanet in history. First to have its actual color measured, Hubble, 2013. First temperature map, Spitzer, 2007. First detection of water vapor, methane, and carbon monoxide in any alien atmosphere. And it's only 63 light-years away. In a galaxy 100,000 light-years across, this nightmare is practically next door. The glass hits your visor, already scarred from iron rain, already heat-warped from WASP-12b, already microfractured from wind shear. The first impact spiders the faceplate. The second opens a fracture. The third goes through. Breach. Superheated hydrogen floods the suit. 1,800 degrees Fahrenheit, pressurized, immediate. Your corneas vaporize before your eyelids can close. Your lungs, mid-inhale, fill with gas hot enough to calcify tissue on contact. The alveoli, the tiny sacs that exchange oxygen, sear shut. Your skin doesn't burn. At this temperature, organic tissue sublimates. The outer layers of your face transition directly from solid to gas, skipping liquid entirely, the way dry ice disappears on a warm day. Except it's not dry ice. It's you. The suit didn't fail from one catastrophic blow. It failed from 7 planets of accumulated damage. Hairline fractures from burning ice. Ablated shielding from a star that filled the sky. Melted boots from a lava ocean. Cracked seals from supersonic wind. Iron-scarred visor. Thermal breach from a dying world. And finally, a faceplate that had been asked to survive too much, hit one more time by one more rain on one last planet that looked like home. Every planet you just visited is real. Every number came from real instruments. Hubble, Spitzer, JWST, the Very Large Telescope, published in Nature, the Astrophysical Journal, Astronomy, and Astrophysics. The iron rain is real. The glass storms are real. The planet being eaten alive is real. We've confirmed just over 5,900 exoplanets. There are estimated to be hundreds of billions in our galaxy alone. These 7 were the worst we've found so far. The suit was rated for all 7. It made it through 6. That's the thing about the universe. It always has one more planet you didn't plan for.